The sun is a colossal nuclear fusion reactor, burning at its core with unimaginable power. Every second, it fuses millions of tons of hydrogen into helium, releasing a torrent of energy that radiates outward in all directions. This energy floods the vast emptiness of space, traveling millions of kilometers and bathing our solar system in light and warmth every second. Yet, only a tiny fraction of this immense energy ever reaches Earth. Most is scattered or absorbed by clouds, lost in the atmosphere, or blocked by the darkness of night. Our planet is just a small target in the sun's endless outpouring. But imagine if we could intercept that energy before it's lost, capturing it directly in space, where nothing stands in the way. In the vacuum of space, there are no clouds to block the rays, no atmosphere to filter the light, and no night to bring darkness, just endless, uninterrupted sunlight. A satellite placed in the right orbit could soak up this continuous, unfiltered sunshine 24 hours a day, 7 days a week without pause. This is the core idea behind space-based solar power, tapping into a limitless, always available energy source that never sleeps. On Earth, we already know how to capture sunlight with solar panels, but we're always at the mercy of weather, clouds, and the cycle of day and night. Our solar harvest is interrupted and inconsistent. In space, those interruptions simply vanish. The sun shines with unwavering intensity, providing a constant stream of energy. We could build power plants in orbit where the sun never sets, creating a new era of energy abundance. This means a steady, reliable flow of clean energy for everyone on Earth, delivered day and night, regardless of weather or season. The scale is staggering. The solar energy passing through space every hour dwarfs all of humanity's annual energy use many times over. We are surrounded by an ocean of power, a vast sea of energy waiting to be tapped. All we need is the right technology to harness it. By placing collectors in orbit, we move from a world of energy scarcity to one of true abundance, where energy is no longer a limiting factor. Instead of sipping from a straw, we drink straight from the source, tapping directly into the sun's endless supply. This isn't just a new power plant, it's a new relationship with our star, a bold step toward a sustainable future. It's about finally embracing the full potential of the energy that sustained life on Earth for billions of years and using it to power our civilization. The technology is within reach. The challenge is to seize it, to build the infrastructure and make this vision a reality. The sun's gift is unending. We just have to learn how to accept it and transform it into a force for good on Earth. The future of energy could be waiting above our heads, ready to illuminate a new chapter for humanity. How do we build a power station in space? It sounds like science fiction, but it's quickly becoming a real possibility as technology advances. The answer, space-based solar power, could revolutionize how we generate and deliver energy on a global scale. Picture a giant solar panel satellite, miles wide, in geostationary orbit, always above the same spot on Earth, silently collecting energy from the sun. Covered in advanced solar cells, it collects intense, uninterrupted sunlight and converts it to electricity, far more efficiently than panels on the ground. No clouds, no night, just constant power generation, 24 hours a day, every day of the year. The next step, transmitting that energy to Earth across the vast distance of space. Instead of wires, the satellite converts electricity into microwaves, a safe and efficient way to send energy through the atmosphere. A focused microwave beam is aimed precisely at a ground station, ensuring minimal energy loss during transmission. On Earth, a rectenna, a field of mesh antennas, catches the beam and converts it back to electricity, ready for use. The process is efficient and safe, delivering power directly into our existing grids, seamlessly integrating with current infrastructure. It's a three-step process. Collect sunlight in space, beam it down to Earth, and catch it on Earth, turning cosmic energy into usable power for homes, cities, and industries. This system could provide clean, reliable energy day and night, helping to reduce our dependence on fossil fuels. The technology is proven in principle. The challenge is scaling it up to meet the world's enormous energy needs and making it cost-effective. Space-based solar power could transform how we power our world, opening a new era of clean, limitless energy from the stars. Imagine a ring of glowing satellites above Earth's equator, a new constellation built by us, stretching across the sky in a perfect circle. This vision isn't just science fiction, it's a bold step toward a cleaner, brighter future for our planet. These solar power satellites, stationed in geostationary orbit, beam energy down to different regions, capturing sunlight in space where it's always available and sending it to Earth, day and night, rain or shine. At night, they'd appear as faint unmoving stars, silent sentinels powering our world, their gentle glow a reminder of the energy flowing invisibly to billions below. Each satellite, kilometers across, is a lattice of solar panels and transmitters managed from Earth. These vast machines are marvels of engineering, designed to operate autonomously for decades. Together, they form an orbital energy grid, a global network transcending borders, linking continents and nations in a shared mission. Energy flows where it's needed, managed by international cooperation. This system could help balance supply and demand, even during emergencies or natural disasters. Building this grid would require thousands of rocket launches, each one carrying vital components into orbit, marking a new era of space industry, and fleets of robotic construction drones, tirelessly assembling and expanding the network high above our heads. Maintenance would be handled by robotic repair missions, ensuring peak efficiency and rapid response to any technical issues that arise. This would be humanity's largest structure, not on Earth but in space. It would dwarf anything we've ever built before. The Ring of Light would symbolize a united planet working for a sustainable future and a testament to what we can achieve together. It's a new industrial revolution, unfolding in the clean expanse of space, where innovation and sustainability go hand in hand. The scale is immense, but so is the potential. This project could redefine how humanity powers its civilization. Our future energy grid could shine from the heavens, lighting the way to a new era for all of us. How does energy travel from space to your home? The answer: wireless transmission. Satellites convert solar power into a focused microwave beam aimed precisely at a ground station. The beam is invisible and safe. Its intensity is carefully controlled, with automatic shutoff if anything enters its path. The ground station, or rectenna, is a mesh field that lets sunlight through, so the land beneath remains usable. Tiny diodes in the rectenna convert microwaves back into electricity with high efficiency. The electricity is then fed into the grid, powering homes and businesses just like any other source. To the user, it's seamless. Flip a switch and the lights come on, powered by sunlight captured in space minutes earlier. The process is silent, efficient, and unobtrusive. It's a direct connection between the cosmos and our daily lives. Space-based solar power could make clean energy as easy as turning on a light. Why put solar panels in space instead of on Earth? The advantages are profound. Ground-based panels are limited by weather, night, and atmospheric filtering. On average, they operate at full potential only a fraction of the day. In space, panels receive sunlight over 99% of the time, almost continuous power. The sunlight is more intense, with no atmosphere to filter it. Each square meter in orbit generates far more electricity than on the ground. Space-based panels provide baseload power, a steady, reliable supply. Land use is another advantage. Powering the world with ground solar would require vast land areas. Space-based systems need only rectenna fields, which allow the land beneath to remain productive. The main collectors are in orbit, taking up no space on Earth. The result: more power, less land, and a cleaner planet. Space-based solar is a leap beyond what's possible on the ground. The vision is inspiring, but the challenges are real. The biggest hurdle, launching massive satellites into orbit, is still extremely expensive. Hundreds of rocket launches would be needed for a full-scale system. In-space assembly requires advanced robotics, machines that can build and maintain satellites in the harsh environment of space. Energy transmission must be highly efficient. Every bit of loss adds to the cost. Scientists are working to improve solar cells, transmitters, and receivers to minimize losses. Managing a global orbital grid demands unprecedented international cooperation, agreements on orbits, frequencies, and safety. These are technical, political, and logistical puzzles. The challenges are great, but so is the potential reward. Overcoming them could change the world. These challenges aren't insurmountable. Solutions are already in progress. Private space companies are slashing launch costs with reusable rockets. Robotics and AI are making autonomous in-space construction possible. Swarms of smart robots could assemble satellites from components delivered by low-cost rockets. scientists are developing lighter, more efficient solar cells and refining microwave beaming technology. Small-scale experiments are underway, proving the concept in real space environments. International cooperation, as seen with the International Space Station, shows we can work together on complex projects. Piece by piece, we're solving the cosmic puzzle. Imagine a world where energy is clean, abundant, and available to all. Space-based solar power could make this a reality, ending energy scarcity and reducing conflict. It generates no greenhouse gases, no toxic waste, and has minimal impact on Earth's surface. Clean electricity from space could power vehicles, homes, and industries, helping us leave fossil fuels behind. This technology could be our strongest tool against climate change. It would also drive economic growth and reduce inequality, bringing power to remote areas. A small rectangle could transform a village, powering schools and clinics. This is more than technology. It's a vision for a better, fairer world. The journey will be long, but the first step is believing it's possible. The dawn of a new energy era could be just above our heads. Humanity's story is one of looking up and dreaming. Now, the cosmos offers a practical solution to our energy needs. Space-based solar power is the next step in our journey, using the vastness of space to secure Earth's future. Building a solar grid in space will drive innovation in science, engineering, and beyond. The benefits will ripple through society, just as past space programs have. This is about changing our perspective, seeing Earth as part of a solar system rich in energy. By harnessing space resources, we become true citizens of the cosmos. Next time you see the sun, think of it as an infinite power source. And when you look at the night sky, imagine a ring of light silently powering our world. This is not science fiction, it's a future we can build together. Our destiny is not just on Earth but among the stars.